well, we're going to show it to you, but it's a kind of challenging project to do in one semester, to do like a kind of Cortana Siri kind of thing in just one semester. But they were able to do it and getting some real working personal assistant. We'll see that.
Yeah, there we go. Hello everyone, this is our project, the LTUAssistant. I'm Chris.
I'm Jacob.
I'm Khalil.
So on our agenda today, we're going to start off with an introduction. We're going to cover the architecture of the AI assistant itself, as well as the technologies used to implement it. We're also going to go over what features it currently supports, as well as our future capabilities and features we would also like to add on to it with more time. Then we'll give a live demonstration of the AI assistant working and have a Q&A session. So first off, I think it's important to establish why we chose this project in the first place. A lot of you are probably familiar with AI assistants like Google Now, Siri, Cortana, that you can talk to, use voice recognition to parse what the user wants to do, and then take an action with that. However, these are all general use AI assistants meant for a general target audience, and they don't have specific skills. Like for example, if you're a student and you want some sort of study aid besides just searching online, let's say we want an AI assistant that can quiz you on material, for instance, or remind you of upcoming classes, then none of those other options will really work for you. So our solution to this was to create a specialized AI assistant that's tailored specifically for students, and our concept can also be tweaked so that it can be used for other specific target groups as well, like say for doctors or the like, depending on what exactly they need out of such a system.
So how did we do that? The design architecture. It was programmed in Python. Python is script programming language, and it works only on Linux, not on Windows, and not on iOS. And we will mention why later on this slide. And it's split into different several components. So you can imagine the supervisor, which is the main component, and all of these components are integrated together. We have a speech recognition component, we have a Stanford NLP component for natural language processing, and we have the execution component. And as you see, this is the sequence diagram for our application. This is the logical flow, and this is the integration flow. And you can see that first we will enable the application, we will listen for the speech, we will convert speech into a text, and then we will analyze the text and take action corresponding. So the way we will launch the application, the main component will call a listen function from the speech component that has a Google Speech Recognition library. We will speak about it. And this library will send the audio online. We should mention that our application doesn't work without internet connection. And it will return the text. Then the speech component will return the sentence all the way to main. Main will call the function parse from core NLP component that does the natural language processing, and it will retrieve like what is the verb in the sentence, what is the subject, and what are other adverbs. It will return it all the way to main component. Then the main component will call the execution component and send these parameters and take actions corresponding, depends on which verb found or what is the subject and what is the other adverbs.
So we use a few libraries, like external libraries. Like we didn't write everything ourselves. So for the speech recognition, it sends it to Google, and they're really good at parsing the speech, and it always knows exactly what we said. And then once we have the sentence, we use Stanford Core NLP, which is written in Java, and it's pretty standard. We use a Python wrapper for that. And that Python wrapper, it only works on Linux, and that's why it didn't work on Windows. But if it wasn't for that, it would work on Windows. And then it uses eSpeak, that's just a Linux command to like say back to you some text. and also it shows on the screen, like it shows a notification for what it's saying.
So what do we have on our application, the features, the current features? So some of the features were based on our perspective, our opinion, like simple tasks like open Blackboard, send an email to a professor, and we wanted to know what other suggestions. So we made a survey on campus. It was like for about 100 students. We distributed a form with questions, and all the students submitted answers, and we collected these answers and made the statistic. So these are some example questions on the form. How would you order the system to send an email to the professor? How would you ask the system to know the on-campus event? And the last section was services you suggest or you would like this application to include. And we see here the data we collected on campus. So as we see, 38 students would say this exact speech, send an email, to example, for sending an email. And 25 students said that they will use this, what is going on campus, to know what's going on campus events. So basically that's how it goes. That's how it went. The survey, we collected this data and we made our scenario, our rules in the code based on a generic case. And you can see this was the section for suggested services. So 11 students said that they want the weather. They want to know the weather on campus, so we implemented that. And also, these might all be like future capabilities and services.
So current features that we were able to implement in this version of the AI system using the time that we were allotted, including linked shortcuts to specific LTU web pages, as mentioned earlier. If you want to go to Blackboard or you want to go to Banner Web, you just tell it that and it will take you there. It can also retrieve weather information on campus from what the current weather is. If you ask it to locate a room for you, it will be able to tell you which building it is, which floor it is. And it can also open up an email client. There's a few other things it can do as well, like you can tweak some settings and ask what the current date and time is. There's some very basic calendar event planning in here that we hope to expand in the future. So future features and capabilities that we would also like to focus on would be to actually have a background daemon running, which would remind users of classes and tests that are upcoming, that are added to the event scheduling. It should also be able to learn class material from the user and then quiz them on it later, sort of like note cards, and ask them questions that they are getting incorrect more often so that they can focus on reading this material and serve as an effective study aid. We want it also to be able to email, text, and call specific contacts, much like the AI assistant that you have on your phone, and of course launch other programs that you have installed. So at this point, we can now give a live demonstration of our assistant and show you a couple sample commands it is able to perform.
We don't have a GUI right now, so you have to launch it from the console.
There's a couple different options that it supports. There's text-only mode, and you can also pass it a command on the command block directly if you don't want to speak it initially. Some of these we put in for our own testing, but they might also be useful to users. My name is Chris. So what you can see here is it first has to start up the core NLP server, so that's able to parse text that it receives. It sends the text to Google, or rather I should say the speech data. It retrieves the string for what Google thinks you said back, and passes it to core NLP to parse it and run command. Another command I passed it. Show weather. There's a couple small things that it still doesn't get quite right with the phrasing, but we plan on ironing those out. Those are all special cases. All current date. Another challenge we ran into sometimes is that the speech recognition library, it looks for energy levels in the sounds that are coming into the microphone, so it might not always read it correctly. Other functionality that we put in, another setting we changed. Use the female voice. Out loud. And it's not always perfect either. In this case, it said I thought I said use a female voice instead of use a. But if it went through correctly, we also have a higher pitched voice it can use instead as per the user's preference. Would you like to give it a try? Yeah.
What is the weather like today? What is the weather like today?
So we have a number of these commands that we can run that it can do. We've also got a proof of concept that hopefully we can demonstrate for recording upcoming events.
Sometimes like the really simple.
Planning event. My class. Today. 9:30 p.m. You can try to ask it to recover those events that are scheduled. What is my schedule? So as you can see, we can put in events. Currently, it only retrieves events that are planned for today, but in the future, we'd like to expand it so it's able to retrieve events that are planned for other days as well. This feature is largely a proof of concept, and we would like to take it further. Oh, sure. Let's finish off with one more command.
Chris, you're running out of time here.
Open Blackboard. As you can see, it opens up a web browser, and we have Blackboard. So that's all the commands we're going to show for today. And we're ready for questions and answers. Sure.
I know you said you use the Google API. Are there any things you can run on your desktop in case you have like some kind of embedded application for when you go on the internet, or is it basically Google is the best thing that's out there, so you should probably use it?
Early on in development, we tried looking at a library known as Pocket Space, but that didn't give us very good results. We decided to stick with Google largely for the accuracy of the return results.
Yeah, because it was almost never getting accurately what I said.
That would be nice to add in the future too, though, in case the user doesn't have an internet connection or Google's unreachable for whatever reason. Sure.
Are you guys looking to expand mobile devices?
Right now, currently, this runs on desktop Linux.
Right.
And it's written in Python. It's a matter of being able to port it to other devices. We may or may not be able to target mobile in the future, but right now we're only aiming for the desktop.
Actually, I got a question. You guys said that there's a wrapper that is written in Java and it's Linux only.
The kernel key is written in Java, and the wrapper we're using for Python 2 is only for Linux.
Okay, so would it have made more sense for you guys to actually write the application in Java?
I mean, maybe, but we decided to use Python pretty early on, and I mean, there are a few Python wrappers actually. I've looked at two of them, but the other wrapper I was looking at, it wasn't as good. Like it didn't return as much information.
Another thing too is that looking at the wrapper as for why that only works on Linux, it has something to do with the choice of pipes they use that can only be used on Linux systems, but not on other operating systems. So we might be able to patch that so it's more cross-platform and be able to bring it over to Windows.
Have you guys looked at the library called Jacqueline at all? It's essentially a parser for Python, except you can run it in JVM.
We stayed with just the standard Python interpreter that comes from Ubuntu Linux. Thank you very much.
Then are you a second?